Am I recording? Yeah. So once you have Rhino open, it's just typing Grasshopper, right, into the command bar to pop up Grasshopper on the side. And I like to have it split up this way, where you have the perspective on half the screen and Grasshopper on the right. So with Grasshopper, we went a little bit over last class. I just kind of give you like a flash of everything that it's about. But to really getting to start using it, you're not really going to know any components right off the bat, right? So you're going to have to do a bit of exploration. So to navigate through the tabs, right? If you have the normal Grasshopper, you'll probably have up to here, display, right? And then every plugin you install will, unless it says that it drops into somewhere else, like there's some plugins I think that I have dropped under curve utility. But generally, if a plugin comes with its own array of tools, it'll have its own toolbar, right? So the two plugins, you're gonna see this later in the assignment, but maybe want to write it down now. The two plugins you're gonna use for this first assignment are Weaverbird, which comes in its own standalone website. It doesn't appear on Food for Rhino. Food for Rhino, if I didn't mention this last class, but it's a website where it's basically an open source. Anybody who comes up with a plugin puts it on there. Most are free, some are paid, but everything we use is obviously free. So you're going to need Weaverbird, which isn't on Food for Rhino. You're going to have to Google and find its own website. Some people have said it looks sketchy. It's not sketchy. Just download it and install it. And Lunchbox over here, that is on Food for Rhino, and it also has just an installer file. They're both very easy to install. So one is basically, they have a wide range of tools, but we're going to focus on the paneling tools in Lunchbox, and we're going to focus on an array of tools in Weaverbird, but we'll get to that. So how it works is you have different categories, right? You have your parameters, your maths, your sets, vectors, curves, surfaces, meshes, intersections, transforming, and display, right? And under each one, you have the subcategories, right? So under parameters, you have parameters that are done for geometry. Some that are done for numbers or different data inputs, which are under primitive, right? Different inputs for different sort of things, like inputting mathematical graphs or colors or numbers, right? Or even text. And then util, which are very interesting. And if we have time, I'd love to show you guys Galapagos, because that'll be very interesting. So maths, right? This is everything that's going to operate on your numbers or on your scripting. Here you can see I have C# and Python plugins installed. So those, for example, are some things that you have to go on Food for Rhino for and install, and they're going to drop into where they're supposed to go within your toolbars rather than creating their own. You have sets, which control lists of things, right? The last time when I created a grid and then I created a curve and we were dealing with different lists, right? Any sort of generating lists of data or lists of geometry and manipulating those is going to go under sets, right? Vectors are forces or directions, right? So that basically controls anything from where something is moving to which way is a surface facing, right? And that sort of thing. Curves, obviously. Lines, curves, interpolated, control points, all that stuff. Surfaces, I think I mentioned last time, you have surfaces, right? And then the word brep just kind of stands for anything that is related to a surface. So open poly surfaces, right? Closed poly surfaces, closed extrusions, right? Anything that's sort of interpreted as a surface will be read as a brep. You'll see that repeatedly. Then you have meshes, the difference between a surface and a mesh. I explain on a couple posts and videos online. If you haven't checked any of that out, I'll give you a link later. But it's basically how the program reads those 3D objects. There's a difference between a surface and a mesh. Not important right now. Intersections, right? So you can find any sort of data that collides between one geometry and another, curves to surfaces to meshes, etc. So to get started, you obviously need something on your canvas. So your canvas, you can zoom out and you can create a pretty sizable script. This will always lead you to the origin, right? This top corner of your script, if you ever make one that's complicated. And then I like to make sure I see the grid when I'm typing in components. So we'll start with a very simple one, right? If we go to Actually, I'm not sure. I think construct point right here. Points are also under vectors and also planes. It's a bit more complicated and technical, not necessarily important right now, but in order to start a point, right, we understand that a point or planes are under the vector tab. Very simple data. And if we go under point, right, we want to start from there. We have a number of options, right? So just hovering over anything is going to give you, right, the title and a little description that's going to give you a hint as to what it does. So obviously construct point calls out, and I've used this before and I've showed you guys before. So construct a point from XYZ coordinates. Very simple. So when you click on something up here, it's going to attach to your mouse header, right? And you just click anywhere on the canvas and it'll drop there, right? If you know what you're looking for, double clicking on the canvas works for searching. So I can search for a construct point, and I can use my arrows to go through the options, and then enter will just place it right there, right? So here I have 2 points, right? And this is what a component, right, looks like. So you have different types of components, right? You have these which create actual geometry or visual data, right? And that's the output here, point, right? This is the node that represents that outgoing data. And then here are all the inputs, right? And all the nodes represent incoming data. So hovering over any one of these inputs or outputs is going to give you more information, right? Including a symbol, which directly relates to something that you can input. So I see that symbol, right? 0.1. And I remember everything in white text within a black symbol almost always relates to the params, geometry, or primitive tab, right? So I see that 0.1 right here, that's related there, and I grab that and I put it there. Now these components from the param tab are all either collecting geometry and passing it through, right? So let's say there's a number I want for the x coordinate, I'll connect that there. There's a number of things I can do with this, right? And what I mean by it either collects or creates data is that when it's the standalone thing, right, and hovering over it isn't giving you enough information, right-clicking it is going to give you options and more information, right? So you have help at the bottom, right? It's going to give you a full description of what it does and even like remarks, like different ways that you can use it. But if I right-click on it, I see I have like set number, set multiple numbers, right? So I can set a number, 5, enter, commit changes, right? So now we see that 1 point has moved 5 units, right? 1, 2, 3, 4, 5. In the x direction along the red axis, right? And that's following whatever unit. Oh, you can't see up there. No. So it follows whatever unit you have in Rhino, right? So if I'm working in inches, this number right now is 5 inches that way. That point is 5 inches that way. I can also, if I have multiple number sliders and just double clicking and entering any number, we'll create a number slider. I've mentioned before that if you type in between 1 and 10, you'll get a number slider between 1 and 10. If it's larger than 10 but under 100, right? Or if you type in decimal points, those will get, right, added into the slider. So when you have multiple things, right, let's say I want to create 3 points, all with these different x coordinates. I can hold, right, this node, and while holding shift, I see a plus sign come up, right? So I don't need that necessarily now. I just plugged in this first one into number, and now it overwrote the 5 I typed in, and it's now carrying that 10 through, right? That's what I mean by these param components that can either create or transfer data, right? And the benefit here is that I can hold shift, as I was saying, to add another node, so I can connect 2 numbers here, right, by holding shift. Now I'm creating those multiple points. Right, it's combining these, and the reason it's creating multiple points, right? If I hover over here, over point, it says now 3 defined values, right? So you start understanding that putting in 3 values at the same input is going to create more than one output, right? If there's overlapping data, right, meaning that there's more than one thing coming in to an input, it'll have to create multiple to make sense. Right, you can't have a point have this x-coordinate and this x-coordinate and this x-coordinate. They're going to be 3 separate items, right? So now if I plug this number into y-coordinate, all of them are going to move that way, right? Why? because this one data is being applied, is applicable to all of them, right? There's no overlap, right? That data can flow perfectly. However, if I copy paste and do the same thing for the y coordinate, right? Remember we talked about last time how data carries through. So right now we have 3 numbers matching to 3 numbers. So each one is getting 1. So 8, right, is correlating with 8 because they're first in the list. And the list is determined by the order I connected them in, right? Not the order that they're top to bottom. But I plugged in 8 first, then I plugged in 62, then I plugged in 64. And when I copied that, that order was saved. So 8 is matching with 8, right? So that's over here. If I move that, oh, that's over there. Never mind. So that's 62 probably. So if I lower 62, right, it'll move on those axes because this is y and that's x. I can also use the same number slider, but that would mean I have to reconnect everything. So what I mean by that is if I connect 8 over here to make it the first one again so that 8 matches with this first number slider. Sorry, I'm getting confusing. So if I disconnect all of them here, right? No, that's not what I wanted. So if I want 8 to match with 9, right? 9 would have to be connected first because 8 was connected first here, right? But let's say that instead of using this one to relate to this one, I want this one to remain the same on both. So I just bring that in as my second one while holding shift. And then 6.4 is going to relate to 6.4. So I'm going to bring that one in third, right? So what we see now is that these coordinates, right, the way they're manipulated, sorry, when we move the x for this one, right, that same point uses this first item for the y, right? When I look at the third point, right, represented by these last inputs, I can also move those 2 coordinates independently. But because this number slider, right, comes in second for both components, that second point is going to move on both axes simultaneously, right? Does that make sense? So that's really like a crash course on inputs into creating geometry.
Does it make sense,
right?
really? I got confused a little bit.
Yeah, what's up?
I got it up to when you copied and connected it, but then when you press connecting the bottom one, the top one's the bottom one.
That's where you get lost?
Yeah.
Okay. So let me do it this way, actually. If you don't collect numbers like that, I could do 5 on x and 5 on y, right, and move them independently, right? So you see it moving along the y, like the green direction. That's the y-axis. So you move it along, you see it moving along that axis. And then here you see it moving along the x-axis, right, because it's connected to x coordinate. So what I'm saying is simply that once you replace that and you put a number slider into the same direction, what should happen to this point if I move the slider? It'll move both ways, which means it'll look like it's moving diagonally, right? Let me show you a different way. Rather than using shift, I'm going to use a merge component. So this is actually going to show up in your assignment. So this does the same thing as holding shift and making various inputs. So if I create a number slider here for data 3, and then I create a different one for data 2, we're going to get the same thing as before. We're now, oh, never mind. 3, 3. Oh, well, right, they're just overlapping. But, so that does the same thing, right, as holding shift and carrying through. So to illustrate what I was trying to say, is that if I just copy this for the other coordinate, right, it's going to match up to those points. So the values are the same. So they're set up diagonally, right, how we had talked. If I change these, I'm only changing one axis, right? D1 and D1 are creating point D1, right, are creating this. If I open up a panel, and a panel can be used for looking at output data, right? Data 1 is going to make this first point on the list, right? And so we see data 1, 7, popping up here. X, Y, Z, right? We're seeing 7 pop up in the Y, right? We see how that's carrying through from here to here to there. Does that make sense to everybody? Yeah? So what happens now if I plug in this one over here, right? All I'm saying is that that's going to change the properties of that first point. But look at the output data. This number slider is only changing the first point, but it's changing 2 of its values at once. Right? Whereas the only difference is that these have their independent sliders. Does that make sense? All right. It's a very, very simple thing, but I'm trying to get you to understand the most complicated thing about it, right? Because that'll make everything seem a lot easier. So this is what you're going to need for your assignment before I start explaining it, is a series, right? This is the first exercise in your assignment. If there's time, I'll try to do the first exercise with you so you can do the rest of the script yourself. But we'll do a series, right? And this is found under sets, sequence, series. Create a series of numbers, right? Really simple. And we're going to use a construct point to illustrate this. So it does the same thing of carrying through many outputs, right? Many data items for one input for the x coordinate. So it's creating many points, right? So we're in the same situation as before, except this time, rather than coming directly from number sliders, we're using a series in between. So let's take a look at the series, right? If we hover over it, we see 0.0 as our start, right? And then we see step to 1, right? And if we investigate our points, we see that there's actually a point on 0, and then the next point is occurring 1 unit along the x, right? Along the x-axis. So we understand that this first point, right, is happening at that first value, the start value. So we can create a number slider for that. And if we put in 2, we can actually observe, oh, that point moved 2 units, right? My step is still 1. So here's where I can use the same number slider for start and step to have everything evenly spaced out. Right? So as I move this first point away, I'm also changing the distance between all the points. That's why I wanted to explain having one input be placed into many places, right? Or one data item, the number slider, going into several inputs, right? Because that's the kind of result that you get. So count here is 10, right? Which means I have 10 points. So that's fine. I don't need to put anything in there if I want 10 for now, or if that number doesn't really matter. I can just leave it to the default. I could also, right, if you want something to be dependent on another, I can multiply by using a multiplication, right? And this is found under maths operators, right? You can just multiply numbers together. And I'm going to multiply 6 with 2. Right? So now the amount of points is dependent on their spacing. The more spacing there is, the more points there are. When the spacing is 10 units, there's 20 points. When the spacing is 8 units, there's 16 points. Right? Okay. So now this isn't relative to your assignment, but this is why I'm taking my time explaining to you this data input, is because you then get to some very cool stuff if you know how to format your data, right? So this is what Galapagos is. And this is, as soon as you are able to write a script on your own, you can start using this, right? This is what I want to show you. So this comes standard in Grasshopper, and it's basically like a natural selection sort of mimicking thing, machine learning baby steps, right? So you have your fitness and your genome. Right? So your fitness is a numerical number, right? It's a value, numerical value, that you are either trying to make as large as possible or as small as possible, right? So construct point, and then genome is the numbers that you're going to alter, right, to try to achieve that maximum or minimum. So let's just say I make 2 number sliders, right? One for start and one for step. And I connect from genome to that number slider, from genome to the other number slider. And then you see that holding shift also for Galapagos if you're going to do more than one. And then fitness, I'm just going to do something arbitrary and change like the, no. I'm going to do list length. This is kind of arbitrary. It's going to find itself kind of in a loop because actually, sorry, I got to make up my mind. I'm going to do a polyline, right? And obviously the length of this polyline, if I measure that, the length of the polyline is going to change according to the steps, right? And I'm going to keep the amount of points the same. But according to the start and step, it's going to calculate the length of the curve made through the entire points. So, sorry, go to number. So what I'm trying to do, what I'm trying to fitness is this number, right? So again, just an overview. We have these inputs going to start and step on our series, right? We have a multiplier, just changing our count, but that's staying the same. That's not being altered. It's all going into an x coordinate, right? And it's creating a polyline with all those points. And then we're measuring the length of that polyline. And that's the number that we're finessing, right? So when you double click Galapagos, I'm going to say maximize that length, right? I'm going to put a time limit on the process to just a minute. And when I go to solvers, this is what I'm going to look at, right? So 1 second, let me put Grasshopper aside. So what this is going to look like is it's going to go through absolutely every possible value, right? And it's going to start picking up information. And then when it starts picking up information, it's going to start eliminating options. And as it starts eliminating options, it's going to look for options that work better, combinations that work better. And you can see in this graph, it'll eventually start hanging out up here.
What did you change in the options? Just maximize?
Just maximize or minimize, and I added a maximum duration to the analysis. So in this case, I'm only going for a minute. So then here you have different preview options. So you can preview all of the results. You can preview the best results so far, which has been that one, right? Or you display none. So I want to see the best one so far, which is this one, and still testing, and it's going to keep going. But if it doesn't find any one better than this one, it'll just stay to this one, right? And this result is represented up here as the best genetics, right? According to what you're testing for, which in this case is maximum length.